Hi, and welcome to reInvent 2020. This session, DAT 315, will be covering an interesting use case from one of our customers, ADP, on their use of Amazon Neptune. My name is Taylor Riggin, and I'm a Senior Specialist Solutions Architect here at AWS, covering Amazon Neptune and graph databases. For those that may not be familiar, graph databases are used to query and model highly connected data sets. They are part of our purpose-built database strategy, allowing customers to address their access patterns for their data sets using a purpose-built database. Databases such as graph databases are used for things like fraud detection, knowledge graphs, be able to query against social networks, build things like identity graphs for customer 360 workloads. So today we're going to learn about one of those interesting use cases. ADP has built a capability where they're looking at virtual teams internally using social graphs. So with that, I'm going to turn it over to Zed and Kantal to talk about their use case. Take it from here, guys.
Hello, everyone. Thanks for joining our session. My name is Zed Masood. I lead our engineering organization at ADP's Next Gen HCM. I'll be joined by Kuntal Roy, who's our Senior Director of Engineering, later in the presentation. We're going to take a few minutes to tell you more about our use case for Amazon Neptune. We're going to introduce ADP's Next Gen HCM, tell you more about Amazon Neptune in our environment, how we picked Amazon Neptune, and some of our learnings in running Neptune in a microservices environment on Amazon EKS. If you are interested in learning more about how to use graph database for your use case, looking at alternative technologies to maybe some existing databases you have, such as relational databases or other graph database technologies. This session will tell you more about what we learned when we adopted Amazon Neptune to help you understand how you can better use a technology like Amazon Neptune for your graph database use cases, and also consider some of the learnings that we've had in this process so that you can use those learnings in your own experiences. So we hope you find this session useful, and we're going to start with a little bit more background about our Next Gen HCM product and technology, and why graph databases were a good use case for what we use Amazon Neptune for. Our next-gen HCM platform at ADP is based on 5 key pillars. First, we embrace the notion of dynamic teams. Dynamic teams really model the agile modern workplace. If you think about how work actually gets done in many of the environments that you might be used to, and many of you might be within, say, a software engineering, software development type of background. So think about the way that a software development team is made up and is composed of. You've got people from your product organization, engineering, as well as project management. And all of these team members are coming together to make one product, and they have a shared objective. This does not reflect the traditional organizational structure or hierarchy. It's more of a dynamic team. You could think of examples for some of our customers in retail, for example. You might want to model everybody working at one given time or shift, right? So what we've been finding more and more is that since organizations work this way, human capital management platforms and products have not really kept up with this continuing shift in more flexible type of structures and dynamic teams. And this is really where a technology like a graph database for us becomes extremely useful, because we get away from unwieldy relational databases and are able to model these structures a lot more flexibly. Second, there is extreme personalization in today's modern workplace. There's more and more flexibility in terms of the way people work, the hours they work, and when they expect to get paid. Third, global compliance. ADP has a long history of compliance, and we operate in many different countries around the world. So you know that if you're looking to set up an office in a certain geography and you want to make sure you're globally compliant, you can count on us. Fourth, we have a lot of insight and data. So think about things like gathering like salary information and making decisions on that. Well, we have more than 90 million anonymized employee records, and we can use that data for you so that you can get actual data in a summarized, anonymized fashion and really drive some action from real data as opposed to like crowdsourced types of products where the data might not be as accurate. And last but not least, the adaptability of our low-code app development platform ensures that businesses can stay up to can change at a quick rate, right? So as a business, you want to change quickly. Your technology won't allow you to change as quickly, and therefore you might get stuck and delayed in some of the changes you want to make as a business. So that's really the fifth pillar. The focus of this session is going to be on our dynamic teams pillar. It's really one of our most important pillars, and we're going to tell you more about how these dynamic teams help to empower folks, but more importantly, how do we use Amazon Neptune to model these dynamic teams? We're going to do a deep dive on that and show you how this works for us. Dynamic teams help us with fluid team structures. So the real kind of agile notion of the dynamic team, our customers can set up dynamic teams in many different shapes and forms. And we really put this in their control in terms of how they want to create these teams, what types of rules they want to set up. So authorization, for example, is an extremely important use case for us, where you can set up authorization grants based on dynamic teams that you've set up and configured, ultimately represented in our graph database with Amazon Neptune. This really helps us empower team leaders so that you have greater insight into the actual team that you're working with, and you're able to slice and dice that in a way that makes sense for you. It gives us critical insights in terms of things like metrics, and we're able to report those metrics out in these agile teams. And the data retrieval is much more flexible. So if you think about certain approval flows, data that needs to get queried from dynamic teams through a graph database, that really puts it into the hands of customers. So to tell you more about Amazon Neptune in our environment, our platform is composed of over 200 microservices. This enables us to create microservice domains across the entire platform. And Amazon Neptune is one of the databases that we use in this ecosystem. All of these microservices run on Amazon EKS. And we have multiple database technologies at play. We use RDS for relational data needs, Elasticsearch for text search needs, Amazon Elasticache for in-memory storage, and Amazon Neptune for querying our dynamic teams. This is a vibrant ecosystem of microservices, databases, and and Amazon Neptune works within all of these moving pieces. And we've got some eventing and data streaming at play here as well, where we replicate data from Amazon RDS to Amazon Neptune. With that, I'm going to turn it over to Kuntal to tell you more about why we picked Amazon Neptune and to do more of a deeper dive into our learnings with EKS, as well as show you a demo on how we load data into Amazon Neptune.
Thank you, Zed. Hello, everyone. I am Kuntal Roy, Senior Director of Engineering in ADP's NextGen HCM Solutions. Before I begin, let me start off with explaining the nature of data that we deal with here in ADP when we're building ADP's NextGen Solutions, NextGen HCM Solutions. Zed, a few minutes back, explained things about dynamic teams. But, well, that's a great use case. Let's talk about very basic information about an employee. It involves things like finding somebody's manager, somebody's direct reports, or even in some cases finding their peers, right? So as you can see, we are dealing with a lot of hierarchical data, right? Which means that we're dealing with DAGs, or directed acyclic graphs. Now, if DAGs are the use case, or the fundamental nature of data, we were looking for database which handles graph traversals out of the box natively. We had looked at multiple graph databases in the past, and ultimately went with something which we built in-house. It did its job for the time being, but as we were scaling out, some of the shortcomings were very apparent. Back in 2018, when Neptune was announced, it kind of caught our attention for five main reasons. One of it was open standards, high availability. Then you had security, compliance, and it being a managed service. Now let me walk you through each of these aspects and how it relates to us in when we are building ADP's next gen HCM solution. Um, Let's talk about open standards and bulk loader. In ADP's next-gen solution, what we do is we are scaling out. We are loading customers each and every day, and we want to load customers' data as fast as we can. And that's where Neptune's bulk loader comes in very, very handy. In Where we were able to load a mid-sized customer from hours to minutes, which is tremendously sped up the time it takes to load a customer. And not only that, um, uh, Neptune provides support for open standards, open query languages like Tinkerpop Gremlin, SparkQL. And the advantage that you have with that is most graph databases that are out there support this open query language out of the box, and that makes switching technology, that makes switching cloud providers if needed, that much easier. You're no longer locked into a specific technology or even a cloud provider, because most graph databases out there supports this open languages. Let's talk about another very important aspect of it, which we considered when using or when picking Neptune. That was the managed services aspect of it. Our goal in ADP's next-gen HCM solutions is, while building it, is to deliver value to our customers. We want to focus our time and energy on building our product where we deliver value. That's where we don't want to be dealing with things like database licenses, backups, patching, failovers, things like that. I mean, that's where the managed service comes in very, very handy, and that's where you see the true power of a cloud native architecture. You don't even need a pool of database engineers who are just maintaining or operating database clusters. You can focus your energy on building your product which actually delivers value to our customers. Let's move on to the next one. I think that was one of the things that we were looking at. Zed mentioned about dynamic teams. Now, in dynamic teams, you have a configuration where you have an employee A connected to employee B and connected to employee C. And employee B has their own manager, employee C has their own manager, right? Now, they're all forming a dynamic team that which represents a ground reality. The way we do it is, and the managers are not directly connected to an employee. The way they are connected to an employee is via positions, right? Via the position they manage. So, and when we looked at Neptune, we were looking at, should we do the traversal from a vertex to a vertex? Because it's not an employee vertex to another employee vertex, there is a position in between. So we were thinking of, should I create a derived edge, or should I just make it represent the real life scenario? What we saw when we were comparing the performance, we saw like the performance of whether you create a derived edge between an employee to an employee, or whether you go via employee to a position to another employee, it's very close. It's we roughly saw plus minus 5% difference in performance, which was, I think it was great for us. We could actually represent the real life, how the real life the modeling in Neptune itself. Not only that, I mean, every customer is unique. right? Their schema is unique, their data model is unique, and that's where Neptune's schema-less architecture comes in very, very useful, right? You do not need to have a predefined schema. You model it as it exists today, and not only that, it has its own very fast optimizer, in fact, and you have the integration with Amazon's Elasticsearch, which gives you full text query abilities as well. Another important thing that I think Zed briefly touched upon was we are fully microservices based and it's fully distributed, and we do send across change data capture events from one system to another system, and that's where having Neptune's streaming capabilities comes in super handy, because I can keep the downstream of Neptune in sync with Neptune, and I can relay the changelog events one after the other. Moving on to the multi-AZ and the high availability aspects of it. I mean, with managed services, you kind of expect that out of the box, but just to call out that Neptune is tolerant for the multi-AZ failures, both from memory as well as at a compute level, and it does support auto failovers. Finally, on the compliance and the security aspect of it, uh, Neptune provides encryption at rest as well as transit, and it is SOC 2 compliance, and it helps us focus our energy on building or looking at security aspects on the service side rather than focusing on the database side, because it comes out of the box compliant with what we need. With that being said, I will move on to a quick overview of how we use bulk loader in ADP's next gen HCM solutions. I'm going to us through a quick high level overview about what the high level components are. On the top left, you would see Amazon IDS, which is our source of data. In the middle, you have the bulk service, which pulls data from Amazon's RDS and exports it as CSV, uploads it to S3, and calls the Neptune's bulk loader API. Now, the bulk loader will while it is loading, there is also a read service you can see on the bottom left, which is also pulling data from Amazon's Neptune as well as from like Amazon Elastic Cache, depending on the usage, whether it is either directly querying a database or it is hitting a cache depending on the usage. With that, let me walk us through a quick demo of how the bulk loader in action. As you can see, I have an S3 bucket open. The S3 bucket is empty. I'm going to start off with querying the graph. You would see that once we query the graph, there is nothing in there. There are like 0 vertex. And we'll quickly switch on to running a script where we are going to take the data from RDS, upload it in S3 as CSVs, and trigger the bulk load API on Neptune. We are going to check for status to see if the Neptune's bulk loader API has been triggered. Looks like it has. Now let's switch back to S3 and see if the files have been loaded. It has loaded. Let's open a vertex file and see what it has. Um, As you can see, I mean the CSV file has two meta columns, right? There's an ID column, and then there's a label column, which basically is representing the primary key, and there is bunch of columns which is the format is a name column, the data type, right? You can have strings, numbers, date times, all of these are supported. Similarly, let's open one for an Edge file. You would see a very similar format. Let's give it a minute for it to be downloaded. Yep, as you can see, there is IDs, there is from and to and label, and some additional properties that you may want to add. I mean, it is a property graph in our case. Then let's go back to see where we are with the bulk loader. Looks like it's done, and it took a few seconds, couple of seconds to upload the data. Let's query the graph now and see how many like vertex and edges have been loaded. Roughly Looks like we have loaded roughly 1600 vertex and roughly 1500 edges, and you can see the different types of properties that has been loaded for both vertex as well as an edge. Okay. With that being said, um, let's okay. So Neptune's bulk loader is super fast, reliable. It's very easy to use with CSVs as output format, but it does come with its gotchas. I mean, we have to keep in mind that this is a batching solution. So if you're looking for transactional guarantees, it is not going to work, right? What we need to do is, and what we did, we learned it kind of when we were doing our initial POCs, that I mean, there would be situations where the writes will fail, and what we have to do is, or what we did rather, is we use our application specified IDs and we retried the bulk operation with upsert. So that way, even if it fails, you can still do an upsert, and the upsert becomes, or the retry of the bulk loader becomes safe. It becomes a safe operation. You can retry it multiple times. Not only that, when you are loading data into Neptune, I mean, since it is a heavy operation, depending on the amount of data that one is loading, your read performance, if you're reading directly from the writer node, will be impacted. And that's where Amazon Neptune's the read replicas, you can spin up 15 of them, comes in super handy. You can keep reading from Amazon's reader instances while the bulk operation is happening on the writer node. And what we have seen is typically the latency between the writer and the reader is less than 100 millisecond in most cases. That's what we have noticed. So as long as we can take care of the consistency issues with application specified IDs when retry with an upsert, and we're going to reader nodes instead of writer nodes, and we have the read write isolation there. I mean, the bulk loader comes in super handy when you want to load a lot of data in a fast and a super convenient way. Okay. Now, we do use Neptune in a fully microservices environment, right? There are domains of microservices, which Zed briefly mentioned, and it's running on Amazon's EKS, right? Now, when we are trying to integrate this in Amazon's EKS, there are a few learnings which I wanted to share with you. First and foremost thing is, if you have a service which is dependent on Amazon Neptune, we have to keep in mind how do we check the health and the readiness of Neptune. So Neptune does a good job of exposing the status endpoint, but what we did was, while we are leveraging the status endpoint, we would also have our own like a query which we run periodically to check the health of the graph. This is basically checking that I can establish a new connection, or I can or the data exists, right? This is like an additional layer of check. Not only that, I mean, we are in a distributed system, we are scaling out, so there will be situations where you have a failover event, or where you are adding more nodes, where you are adding or removing nodes, right? So it's important to listen to those events and handle them proactively, right? We reconnect when there's a new node being added, when there's a node being removed, or even when there is a failover. That way you do not get like, you always do not go to the same nodes which may or may not be active anymore, right? uh, Also, one other very important thing to consider, which we found out, was we use WebSockets to connect to Neptune. Now, WebSockets by default will establish a connection and keep it open. Now, in many cases, because of network errors or some different kinds of errors, what we have seen is, while in the service layer we see that the WebSocket is open, but the WebSocket is actually closed. So it's very important that we handle the close error and the socket error events when some error is being thrown, right? And not only that, it's important to reconnect, but reconnect with an exponential back off, so that you do not overload Neptune and you do not get into where the multiple services trying to reconnect at the same time. Uh, there's also one other thing to keep in mind is related to the stickiness, right? Where you connect to a reader node and you remain connected there, right? Now, if you have multiple services which are all trying to connect, And if you do not do a DNS resolution every time, what will happen is many of those requests will go to a single node, and all the requests will be processed by the single node. So there are few nodes which will be overloaded, there will be other nodes which will be underloaded. So in order to do the efficient utilization, what we do is every time we reconnect, we do a DNS resolution over again. And this also helps us avoid stickiness. We have 15 reader nodes, and we want to be able to utilize each of it efficiently. While with WebSockets, you will get that level of stickiness, but at the same time, if you're maintaining a list of connections, you open it and make sure the connections you're not going to like one node, one reader node. It is going to the multiple reader node. With that being said, that's all I had to share today. Thank you so much for your time. We also have a related session where we are doing a deep dive on Amazon's Neptune DAT 309. Please check it out. Thank you so much for your time.